From the following frequency distribution graphs, select which one is drawn using bars to represent frequencies without spaces, and this is important, between adjacent bars. Now, if we were just looking at this part here, where bars represent frequencies, that could be a bar graph. A bar graph is something like when you're taking frequencies of categories. So, which type of pet do you prefer? Cat, dog, or turtle? Maybe some people prefer cats, some people prefer dogs, and some people prefer turtles. This is a bar graph, and it has bars. But notice it also has these spaces. Whereas a histogram, which is the other graph that uses bars, a histogram would keep track of something like maybe the number of pets in each house in a survey. And so we could have something like this, where we have, once again, bars. However, the bars are all sort of jammed in up against each other. Even if you had a category that has no frequency, like category number 6 pets in the house, there are no responses of 6 pets in my example here, but still my 5 comes right up against where the 6 would be, and the 7 comes right up against where the 6 would be. There's no space in between the categories. So if you have no spaces, if you are looking without spaces between adjacent bars, that's going to be a histogram. It's not going to be a bar chart. Bar charts have to have those spaces. What about a polygon? Polygons don't have bars whatsoever. Polygons are simply when you could have made a histogram, but instead of having bars, you have dots like this. And here, let me make this a little bit more clear. You join your dots with these line segments. It's just a line graph. And so this would be a polygon. It doesn't use bars, so it's not going to be considered here. So the answer is a histogram. Histograms have no spaces between the adjacent bars, and bars are used to represent frequencies.